In this video, we're going to look at the law of sines and the applications of the law of sines beyond just a triangle. So first we're asked to find the angle that satisfies the sine inverse of 0.93. And we're asked to do it in degrees, and we'll round to the nearest tenth of a degree. In our first example, this is only the 68.4 degrees because the sine inverse is only defined for the angles that my answer, being my range, is only defined between negative 90 degrees and 90 degrees. So if I'm asked to find the sine inverse of any answer, that answer is what comes out when I put in the angle that has to be between that interval between negative 90 and 90 if we're in degrees, or negative pi over 2 to pi over 2 if we are in radians. Now the difference between A and B is that B is saying, I want to know what angles would satisfy 0.6. And any angle that's going to satisfy that is going to be, the first angle is going to be 36.9 degrees, plus any coterminal angle, so 360 degrees K. So that's the location, and anything coterminal to 36.9 will give you that answer of 0.6 if I were to take the sine of that angle. The other place in which we will get an answer of 0.6 when I take the sine of the angle is in quadrant number 2. And that angle happens to be when theta is equal to 143.1 degrees, rounded to the nearest tenth of a decimal, plus 360 degrees multiplied by k, so all the coterminals. So if you stop this, pause this video and put it on pause, and do the sine of 36.9 degrees, you're going to find it's going to be approximately equal to, it's not going to be exact because I don't have exact angles, I'd have to put a lot more decimals in there, the sine of 143.1 degrees. Just like when we're on the unit circle, if I'm asked to find the sine of 30 degrees, this gives me the exact same value on the unit circle as if I was doing the sine of 150 degrees, because of the fact that they have the same reference angle and they're in quadrants 1 and 2, and we know that sine is positive in quadrants 1 and 2. C is similar. So C, they're asking me using only the fact that cosine is defined in the interval between 0 and 180 degrees. That's it. That's all you get. So if I'm doing the angle, the cosine inverse of 0.368, then the only answer I'm going to get is 216 degrees. I don't do anything coterminal to it because it's only defined in that interval between 0 and 180 degrees. However, if I'm asked to find all the angles that satisfy cosine theta is equal to 0.5, I'm going to have my first angle, which is the 60 degrees plus anything coterminal to that, so 360 degrees K. However, if I go down in quadrant number 4 and I let it equal 300 degrees plus anything coterminal to that will also be the solution. So it depends on where I'm standing as to what my answer is. If I want a specific angle, it's going to be asked in this way: find the angle in which satisfies the cosine inverse. However, if I want to know all the angles that satisfy this, if they don't tell me what interval I'm looking at, it is all the angles that are coterminal to the 60 in this case, and all the angles that are coterminal and including the angles of 300. Why do we have to know this? Well, because when we start talking about the law of sines, we're going to have the ambiguous case. And so we got to know that there's going to be times in which we may have two triangles, one triangle, or no triangle. We are now away from SOHCAHTOA. And the reason we are no longer working SOHCAHTOA is because we're looking at oblique triangles. And what an oblique triangle means is that there's no right angle anywhere in it. The way that we usually note the triangle, and it doesn't matter if you start A here or C here or B here, it doesn't really matter, is the angle A, or alpha, is opposite side A. The angle B, or beta, is opposite side B. The angle gamma, or C, is opposite side C. That's the important part. We have, with oblique triangles, these cases. We have one side and two angles, angle, side, angle, and it is exactly what you'd think. You have an angle, the side between, and then the other angle. or you have an angle, angle, side. So you have an angle, and then the next angle, and then the side attached to one of those angles. We have two sides and a non-included angle, which is a side, side angle. So you'd have a side, the next side, and then the angle. It is the ambiguous case. That is the case in which we're not sure if we have no triangles, one triangle, or two triangles. And this is the case that we use when we're using the law of sines. If we have two-sided and the angle between them, it is side, angle, side. And of course, if we have three sides, it's the side, side, side. When we are looking at the law of cosines, we use 3 and 4 for the law of cosines, and we use 1 and 2 for the law of sines. If you're not certain, then start always with the law of sines and see whether or not you'd be able to solve for it. When we have the law of sines, it is the sine of alpha over A, the sine of beta over B, or the sine of C over the sine of gamma over C. There are times, however, in which I will put my side on the numerator and my sine value in the denominator. But the important bit is that relationship must be maintained, in which beta and B are related, the gamma and C are related, and the alpha and A are related. So there's going to be times in which I'm going to write it with my sides in the numerator and my angles in the sine of my angles in the denominator. I would use this if I'm trying to solve for a side. I would use this if I'm trying to solve for an angle. But it doesn't matter. You can use either one to solve for a side or an angle. This is just less work when I'm solving for a side, and this is just less work when I'm solving for an angle. But use whichever one. The important bit, angle and the side, that relationship has to be maintained. If we have the side, side angle, if you're not really sure what you have, you just walk around as you are writing the triangle. It doesn't matter what you put down in this bottom corner. You can put alpha here, you can put beta here, you can put gamma here, but alpha and A must be opposite each other. Beta and B, gamma and C. If we are using, say we are given alpha, and we are given A and B. So we're given the side, side, and the angle. Or you could have done side, side, and the angle. It doesn't really matter. I usually put the angle that's given to me in the bottom left corner, but it doesn't really matter how you do it. So if you have the angle alpha, then the height would be B sine alpha. This is the height of your triangle. Now, if your height of your triangle is larger than the side opposite the angle that is given to you, then you have no triangle. If they're equal, you have only one triangle. It is a right triangle. And of course, if you have A, the side opposite the angle given to you, is larger than the height, and A is less than B, then you're going to get two triangles. A could be coming toward the angle, or the side A could be going away from the angle alpha. So you get two triangles. If you have the alpha, or the A, the side opposite the angle that's given to you, is bigger than the other side given to you, if that happens, then we only have one triangle, and it's not any work trying to determine how many angles you have. If the angle you are looking for, when the angle is given to you, alpha, if it is bigger than 90 degrees, so in other words, it's an obtuse angle, if my angle is bigger than 90 degrees, but less than 180, obviously, you really only have two choices. If A is less than B, you have no triangle. If A is greater than B, you have one triangle. So even though you have the side angle, if the angle that is given to you is bigger than 90 or less than 180, you don't have to worry about the height. In fact, you never have to worry about the height. If you just want to jump right in, everything will shake itself out. So they're asking us to start out with, what is the number of triangles that are given to me? I am given the angle, side. Because I am given angle, side, this is not the ambiguous case. So I just start by drawing my triangle, And it doesn't matter what it looks like. I draw all my triangles exactly the same. I'm going to call this 10 degrees. 10.3, excuse me, 10.3 degrees. That means A must be opposite that because that's where I placed alpha. No other reason. That's a nice place to put it. I'm going to have gamma, which is here. That means C is opposite it, 143.7 degrees. And the C that is given to me is the 48.3. When they're telling me to solve, that means I want to, when I get done, find out what beta is and all the missing sides. I'm going to go with the low-hanging fruit. I know that all of my angles have to add up to 180. So 180 plus my alpha, plus my gamma, plus my beta have to be equal to 180. So in other words, 180 minus the 10.3 minus 143.7 must be my angle beta. Like I said, I'm going to do the low-hanging fruit. And I get B, my angle beta, to be equal to 26 degrees. Now I'm going to use the law of sines to find my missing pieces. It doesn't matter how you set it up, as long as the relationship of C and gamma and B and beta and A and alpha all go together. So what I'm going to do, since I'm chasing sides, is I'm going to put the sides that I'm looking for in the numerator. I'm chasing my side A. It is going to be over the sine of alpha, which is 10.3. This is going to be equal to, and I always go to what's given to me so that I have less chance of a rounding issue. My C side is the 48.3. I'm going to divide by the sine of 143.7. Now I know that A is equal to the sine of 10.3 degrees multiplied by the 48.3 divided by the sine of 143.7 degrees. And I end up with A being approximately, let's round to the same number of decimal places, so we'll round to one decimal place, 14.6 centimeters. So I've found my B, I have my beta, I have found my A. Now I just need to find my B value. So again, I have B over the sine of 26 degrees is equal to, and once again, I go to the given parts to me, which is the 48.3, divided by the sine of 143.7. So it tells me my B is equal to the sine of 26 degrees multiplied by the 48.3 divided by the sine of 143.7 degrees. And I get B to be equal to 35.8 degree, or 35.8 centimeters. Now let's just talk about what I've got. My smallest angle was the 10. My smallest angle is 10 degrees, and the angle opposite my smallest angle, 10.3 degrees, is 14.6. So that makes sense. The angle that is the medium-sized angle, it's like Mama Bear and Papa Bear and Baby Bear. Here's Mama Bear. It is 26 degrees. It is the next angle up, and it has a 35.8 centimeters. Oh, and I should note that that is the final part of it. I've now found all the sides and all the pieces. And then, of course, my largest side is at 48.3, is opposite my largest angle, 143.7. Now let's take a look at my next example here. I have on this B, beta, gamma. So look, my triangle, I write it exactly the same every time. I'm going to put my beta here. So here's where beta is going to be, and I write this as 66.7 degrees. I'm going to put B opposite it, which is 13.6 feet. I decided I'm going to put gamma here because I can. And my gamma is equal to the 39.5, and my C is opposite it. So the first thing I'm going to do is find my alpha. Alpha is going to be equal to 180 minus the 39.5 minus the 66.7, which gives me an answer of 74.1 degrees. So here's my first answer. now I'm going to do like I did before. I'm going to find my missing sides. And I always go back to what's given to me. B and beta are given to me. So I will always use that. Less round off issues. So C over the sine of 39.5 is equal to my B, which is 13.6, divided by my sine of 66.7. And I get C to be 9.418. So there's that piece that was missing. Now I'm going to do the same thing where I have got A over the sine of, we found sine to be 74.1 degrees, is equal to the 13.6 divided by the sine of 66.7. And so I get A to be 14.2. Ooh, what are my units? I should probably only, first of all, I should make sure I've got my units right. My units should be in feet. Should be feet here. Feet. And of course I should round consistently, so I should probably just round that to 1 decimal place. And don't forget my units, feet. And so there's my final piece of the triangle that was missing. And it makes sense. 74 is the largest angle, 14.2 is the largest side. 39.5 is the smallest angle, 9.454 is my smallest side. Let's take a look at C. C, I have, again, I draw my angle, my triangle. Oh, look, they all look the same. I have my alpha here. My alpha is 39.6 degrees. And my A is going to be opposite that, which is 3.7. And my C, it doesn't matter where I put my C, I'll be wild and crazy and put my C down here. And this is going to be 18.4. So what I want to do now is I want to consider the height of the triangle. When I'm talking about the height of the triangle, it's going to be here. This is going to be the height. And I purposely drew this so it makes it a little more difficult to see right out of your eye. What does the height mean? So we find the height. The height of the triangle is going to be the side not opposite. So that's the 18.4. The sine of our angle, which is 39.6 degrees. So I'm going to get my calculator out, and I get H to be 11 point, I'm going to 1 decimal place for consistency, 11.7. Now remember, if we look at our choices up here, let's go back up to our choices. When we're talking about the height, bam, bam, bam. If my height is larger than the side opposite my angle, there is no triangle. So I know that this has no triangle. Now what happens if I were to just jump right in and say, let's just jump right in without finding the H? Cool. I would do I'm chasing an angle now, so I'd put my signs in the numerator. So I'd do the sine of 39.6 degrees divided by 3.7 is equal to the sine of gamma divided by C, which is the 18.4. So what I'd have to do is I'd put my sine of 39.6 times 18.4 divided by 3.7, and I get 3.1, and I'll go to a couple of decimal places. 3.1699 is equal to the sine of alpha. And if I didn't realize right away that that value is bigger than 1, when I tried to take the sine inverse of both sides, I'd get an error message on my calculator. So the simple fact that when I try to do the sine inverse of 3.1699 to find gamma, it's going to tell me, my calculator is going to say, yeah, nice try. That's not true. Not going to happen. I get an error message, domain error or something like that with my calculator. So I could totally jump in and determine whether or not I have a triangle by jumping into the law of sines. But note, that isn't going to tell you whether or not you have 2 triangles. So if you jump right in without thinking about the H, if you have no triangles, it's going to shake itself out. But if you have 2 triangles, it may not shake itself out. In this case, we had no triangles. Let's take a look at the next one. So again, I'm going to draw my triangle, and you're going to be surprised on how I'm going to draw it. It looks exactly like all the others. So here's my A, my alpha, 41.2. I'll put my A being 8.1 here, and here's my beta. Put beta there. I'll put B here being 10.6. Once again, I'm going to find my H. My H is the side not opposite the given angle, so it's going to be 10.6. The sine of 41.2 degrees. I'm going to get my calculator out and see what I get. I'm going to get my H to be 6.982. So I'm going to go back up, see what it said, what happens when my H is clearly smaller than A. And what else? A is smaller than B. So come back up here. I have H smaller than A is smaller than B. I'm going to get two triangles. So to answer this one, I'm going to need to do the law of sines twice. So I'm going to have to first find an appropriate angle for B, because that's the one I'm going to approach next. I need to find the angle B. I have the side B. So I'm going to find my angle B, and I'm going to have two triangles. So I'm going to start with triangle 1. So I'm just going to erase this so I can have triangle 1. So let's start with triangle 1. I don't know why that, whatever that's doing. All right, so I'm going to start out with the sine of beta is over 10.6 as the sine of 41.2 is to my side A, which is 8.1. So the sine of beta is equal to 10.6 multiplied by the sine of 41.2 divided by 8.1, which is equal to 0.86. I'm going to run it out to about 4 decimal places, 86199. So this is the sine of beta. Now, if I do the sine inverse of both sides, I get beta is equal to the sine inverse of 0.86199. I'm going to do that on my calculator, the sine inverse of that number. And I get beta is equal to 59.54 degrees. And let's do consistently, rounding it to only 1 decimal place. Now pay attention to web work, because web work is going to probably want to run it out to like 4 decimal places. I'm going to call this beta 1 because I have to find my second beta. Now what I know is, if you remember from before, the sine of 30 degrees is the same thing as the sine of 150 degrees. So that tells me that the sine of 59 degrees, 59.5 degrees, will give me the exact same answer as the sine of 180 minus the 59.5 degrees. So my 59.5 becomes a reference angle in quadrant number 2. So my beta sub 2 then is going to be 180 minus the 59.5. So I take 180 and I subtract off the 59.5 and I get 120. So 120.5. So this is my second triangle here. Right here is my second triangle. Dun, 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 second triangle. Let's go back to my first triangle though, because I still have to find my gamma. Now, my gamma, I'm going to call it gamma 1, is equal to the 180 minus the alpha minus my beta 1. So my gamma 1 is going to be 180 minus my 41.2 minus my 59.5. So my gamma 1 is going to be equal to, I'm going to go ahead and do this, 41.2, really fast on my calculator. You guys are all doing it on yours. I get 79.3 degrees. My gamma sum 2 is going to be 180 minus my alpha, which was the 41.2, minus my beta 2, which is 120.5. So 180 minus the 41.2 minus the 120.5. And I get my gamma sub 2 is going to be equal to the 18.3 degrees. So I now have to find my C for both of these. So I'm going to come over here and I'm going to do my C first. So my C1 The way I'm going to find that is I'm going to do the C1 over, because I'm chasing C, I'm chasing the side, the sine of 79.3 degrees. I'm going to go back to my given values, which is A and alpha. That's going to help prevent any rounding issues. 8.1 and the sine of 41.2 degrees. So my C sub 1 is equal to 12.1, do I have units on this? Miles. So I've solved my first triangle. My C sub 1, my gamma sub 1, my beta sub 1. Go and finish off this one. My C sub 2. Again, I'm solving for that, so I have C sub 2 over the sine of 18.3. Going back to my given sides, which is 8.1, the sine of 41.2 degrees. And I get my C sub 2 to equal, that's a terrible 2, my C sub 2 to equal 3 point, and rounding 9, and what was my units again? Miles. So here's my second triangle, C sub 2, gamma sub 2, and my beta sub 2. I ended up with two triangles, and I knew I ended up with two triangles because of the fact that my H value was smaller than A and A was smaller than B. We can find the area of a triangle by using the law of sines because we know the area is equal to 1/2 the base times the height. And you would notice we were using the height up here, right? We were using the height to determine whether or not we have triangles or not. So we can do the same thing here, 1/2 the base times the height. What I need to know, however, if we look at this, my area is 1/2. Notice I need to know my B side, I need to know my C side, and I need the angle not opposite any one of those two. So for A, it's already ready to rock and roll. Gamma is not opposite A or B, so my area on this, easy peasy, lemon squeezy, is 1/2 the 12.9 multiplied by the 6.4 multiplied by the sine of 13.7 degrees. Easy peasy, lemon squeezy. And so my area is going to be equal to 9 and for consistency of units, 9.8 units, whatever they are. Should have put some units in here. Units squared. I don't know what they are. Could be inches squared, could be miles squared, could be feet squared. I don't know. I'm going to take a look at B. Now, B is not my lemon squeezy friend. D is, though, so let's go to D. We run down to D. I have my A, my B, and my gamma, so this is just like before. 1/2 my A, my B, and my sine of pi over 3. Now, I can use my calculator, make sure you are in radians, or I know from the unit circle what pi over 3 is. So this is 1/2 multiplied by 6 multiplied by 8, and we happen to know that the sine of pi over 3 on the unit circle is the square root of 3 over 2. So what I end up with, this will cancel with here with a 3, this will cancel here with a 4. I end up with 12, the square root of 3 units squared. Okay. B and C are not nice, easy peasy, lemon squeezy because I have beta and B. I have on both of them beta and B. What I need is either angle alpha or I need side A on the first one. So I'm going to have to do some work before I can jump right into the law, the way that we define the area. Okay, let's find gamma. Because if we can find gamma, then we can go into finding alpha and then the area. Since I'm finding gamma, it'll be the sine of gamma over the 19.7 is equal to the sine of pi over 5 divided by the 23.5. Make sure your calculator is in radians. So the sine of alpha is going to be the 19.7, the sine of pi over 5 divided by the 23.5. And so I end up with alpha when I take the sine inverse is 0.5152. Now this is in radians. So then my alpha, which is the one I really need to find the area, is going to be Now we're in radians, so it's going to be pi minus pi over 5 minus the 0.5152. Remember, we're in radians on this one. So my alpha is going to be 1.998 radians. We're in radians. So now that I've found that, I found the angle not opposite those two sides, I can find the area. Area is 1/2. My sides are 19.7 and 23.5. So 19.7 and 23.5. The sine of alpha, which is 1.998 radians. And so my area is equal to, make sure you're still in radians, 208.5, same units, 0.5 units cubed. And now I'm thinking, did I remember to divide by 2 each time? I don't know. I did. I think I did. Yes, it looks like I did. I don't know if I did. You all need to check this. Make sure I'm divided by 5 on these other two. Now I'm starting to second guess myself. I'm going to just have to check it really fast. I'm going to do 12.9 multiplied by 6.4 multiplied by the sine of 13 point, and I got to make sure I'm in, darn it, got to make sure I'm back in degrees. So 13.7, and then divide that answer by 2. Yeah, okay, cool. Yes, I did remember to divide by 2. Okay, that's the answer for this one. This is the answer for this one. And this is the answer for this one. I'm going to let C be yours. That's one that you can do on your own. You're going to have to do the same thing I did, is you're going to have to start chasing some of the sides. I could not jump right into B by just doing the 1/2, the two sides, and then the sine of the angle not opposite the given two sides. So you're going to have to find B, excuse me, you're going to have to find A, and you're going to have to find C, and possibly alpha as well before you can actually do the area formula. Let's take a look at some applications. There are two types of navigation. We have air navigation and marine navigation. Air navigation is always measured off due north counterclockwise and is always in an angle between 0 and 360 degrees. Marine or surveying navigation is off the north or south. So as an example, this one is off the north or the south. So it's 20 degrees off the north, or 50 degrees off the south, but in the west direction. So pay attention to what they're giving you, and then you're going to have to make that conversion. So we're going to start out with our first example here, which is the NATO exercise, and then that's it. We only have these these examples. We're going to start out with this NATO exercise, and we have this tomcat that left the Nimitz carry on a course bearing 34 degrees. So remember, it is off of the north, always. Everything's off of the north. Here's the north. And it's 34 degrees off of the north. So it's going to go 34 degrees off of the north. And the distance I'm going to travel, like the radius, is 400 miles. Then at some point, I am going to turn and fly at 62 degrees. So what I do is I draw again my north right here. And then from there, I'm going to go 162 degrees off of the north. So I'm going to travel down like this. And this angle is 162 degrees off of the north. We have no idea how far this side is. And then at some point, once I'm going to fly this again, I'm going to write my north there. I'm going to go 308 degrees back. So here's my north. I'm going to go 308 degrees off of the north back to where I started. So this is the 308 degrees. So the triangle you can see is built here. And what they're asking us for is, what is the final leg of the journey? So I'm going to just call this A. Now what I've got to do is I've got to figure out what my triangles are inside, what my angles are. If this angle is 34, then this must be 90 minus 34. So I have 90 minus 34, and that must be 56 degrees. So this part is 56 degrees. It's not the entire angle, but I know it's 56 degrees. The way that I drew this is that this, even though it doesn't look like it, this north and this north are parallel, and this west to east are parallel to this west to east. So I use the fact that I learned back in my high school geometry class that if I have angles that are parallel, or if I have parallel lines, then the alternating interior and exterior angles are equivalent. So that means this one must be 34 degrees as well. Because if this one's 34, the alternating interior would be this 34. It doesn't give me the entire angle, which is what I need, but I do know what this little piece is. I can figure out what this piece is. Let me just make this a little bit larger. I can figure out what this piece is based on the fact that I know from north to south is 180 degrees. So this triangle must be 180 degrees minus the 162. So that triangle, or that angle, 180 minus the 162 is 18 degrees. This entire angle here is going to be the 18 plus 34. So that's going to be 18 plus 34. That gives me 52 degrees. Okay. Now, we're going to go back to the alternating interior angle shenanigans that we had. Let me go ahead and erase this so I can make my north larger. So all of my norths are running parallel. If that other one is 18, then this one has to be 18. Now, I know that I did a full 308 degrees. This thing off the north is 308 degrees. So this angle from the 308 back to the north is going to be the 360. This angle is going to be the 360 minus the 308. That is not the angle I want yet. So I'm going to take 360 and I'm going to subtract 308 and I get 52 degrees. That is not the angle. The angle that I'm chasing is this one. So I'm going to take the 52 degrees. I'm going to subtract off the 18, and that's going to give me the angle that I truly desire. So 52 minus 18, which is 34 degrees. Okay, this is where I am so far. I'm going to redraw my triangle over here with all the things that I know. I know this is 52 degrees. I know this is 34 degrees. I know that this is 400. What I'm asking for is A. I don't have to find anything else. I am now able to actually answer the question. The question is, what is that length A? So I'm going to put A in the numerator. I'm going to do the sine of 52 degrees because that is opposite what I want. I have the 400 and then divided by the sine of 34 degrees. And all of this came from the alternating interior angles of parallel lines. So A is going to be equal to 400 multiplied by the sine, and make sure that you are in, I have to do that right now. Make sure I'm in degrees, and I am. So the sine of 52, 400 times the sine of 52, divided by the sine of 34. And my answer for A is 563.7 miles is the length of that last leg of my journey back to the aircraft carrier. All right. Let's take a look at this one. This is our last example. A survey determines the angle of elevation from the top of a building from a point on the ground is 34 degrees. So you're standing right here, and the angle of elevation from the top of a building to the point on the ground, and that should be the angle of depression, by the way, because you're looking down, is 34 degrees. So what it's telling you is that here's the point on the ground. This is 34 degrees, okay? So then if he, which is the same thing as here, this is 34 degrees by alternating interior angles. If he moves back some distance, we don't know what it is. Actually, we do. It's 54.4 degrees. If he moves further back, 55.4 feet, then this angle that he has as he looks up becomes the angle of 23.2 degrees. What they're asking for is the height of the building. Now, what we know is that we have this triangle right here. And we know that this piece of the triangle must be 180 minus 34 degrees, because that 34 and that angle are on a straight line. So I do 180, 180, clear. 180 minus the 34 is 146 degrees. So we have that angle. We have the 23. We can find this angle right here. And we know that this angle must be 180 minus the 146 minus the 23.2 degrees. So 180 minus the 146 minus the 23.2 degrees is 10.8. So the triangle that we have then looks like this. This is 146 degrees. This is 10.8 degrees. And this one is 23.2 degrees. And we have this, which is the 55.4 feet. Now, it's a two-step process because we want to know the height. So we have to solve for this triangle, and I'm going to call this my A. I'm going to solve for A. So I have A over the sine of 23.2 degrees is equal to the 55.4 over the sine of 10.8 degrees. So A must be equal to 116.47. Now that doesn't answer my question. We're getting closer though. So I'm going to come back over here. What I really want is this blue triangle right here. My blue triangle is producing a right triangle. We know that this length of the radius is 116.47. So I'm going to use tangent because I'm going to use sine because I want this value. I'm going to call this y. So the sine of 34 degrees is equal to my radius, 116.7, divided by, it's my y value first. Y over 116.47. So 116.47 times the sine of 34 degrees is my y value. And that is going to give me 116.47, the sine of 34. It is going to give me y is equal to 65 to the nearest tenth of a foot, 65.1 feet. And that is my final answer. And there is a couple of examples of using the law of sines and finding the law of sines and why it's important. That's it.